So question 1 is to calculate the space diagonal. So the space diagonal is the longest diagonal of a cuboid with a length of 20, a height of 45, and a breadth of 35. So the idea of a space diagonal is if you take two corners at the opposite end of a 3D shape or cuboid, then that's the diagonal that you want. There's two ways to do this. You can either sketch the cuboid yourself and try to visualize this, or you can learn the formula. I will explain how you get this formula. So we're just going to sketch the cuboid in the question. So something like this. Now, two-dimensional Pythagoras tells you that if you know this, we'll call this A, and we will call this B. Then if we have this diagonal, it's called a face diagonal, and it goes from this corner to this one. We call this a face diagonal, and the face diagonal is given by, we'll call this face diagonal X. We won't call it C because we're going to use a C for the height. Now if you have a look here, this is right angled because the face at the bottom is a rectangle. So essentially, at the moment, we're just looking at the bottom face, the rectangle, and that's 90 degrees. It's a right angle. So we use two-dimensional Pythagoras with x being the hypotenuse. And we have a squared plus b squared. You don't have to do all of this, and you can just learn this formula, but I am explaining it through. Suppose we then have the height. This is C. Then what we can get, I will put this in, I think we'll use black for this. Then from this corner to this corner, we have this diagonal. I know this one is hard to visualize, but we then have this diagonal going, and this one is the space diagonal because it goes from here to here. These are the two, or a pair of furthest away corners. But if you have a look, and I understand this will be difficult to visualize, there's a right angle, and you've got the x that we found the last time, this face diagonal, and we have the height. So there's a three-dimensional Pythagoras situation going on. So we can make a triangle out of the x. So we have the x, we have the c, and we have the space diagonal, i.e. this one in purple. We're going to call this one y. So we have y, and again we use Pythagoras on this. Is y squared equals x squared plus c squared. But in the question we're given A, B and C, and it does not matter the order, because we can then switch x squared for a squared plus b squared, and we get y squared equals a squared plus b squared plus c squared. In this context, well, normally the c would be the hypotenuse, but in this case it's one of the 3 dimensions that were given in the question. Although as long as you label what you're doing, you could use any letter for this. And this is the formula for the space diagonal. So let's have a go at it then. So we're going to say the space diagonal, I will write diag for short. In this question we will call this y. So we have y squared equals, we'll put a 20. So we have 20 squared. We have 45 squared. And we have 35 squared. 45 squared. And we have 30 squared. If you then want to find out the value of y squared, if you plug all of that into the calculator, and sorry, I've made a mistake. I should have put 35, not 30. Sorry, I meant to put 35. If you plug that in, you put in 20 squared plus 45 squared plus 35 squared. And just watch for BODMAS. You have to be really careful of this. And that's 3,650. And find the square root, and we get 60.41523. We'll round this to 5 decimal places at the start, and then we will say that to 1 decimal place, so to 1 decimal place, y equals 60.4. There was no specification of rounding, so it's just up to your judgment. But you generally shouldn't be penalised for using too many decimal places or significant figures unless the question unless the question specifies. But if you wrote 60, you might not get the last mark, because that might be considered too few significant figures. So I would always give too many rather than too little, and you usually shouldn't lose any marks. But I think 5 is a bit overkill. So I hope you found this video useful, and I will upload a second one very soon. Thanks for watching.